In this session of DesignWorks TV, we're going to talk about reverse engineering a helical cut gear. Notice on the screen, this is the gear we did, and we're going to show you step by step how we created it. So let's get started. There's many ways to do this. We felt that this would be one of the fastest and most accurate ways to do this. So we're going to go ahead and utilize DesignWorks, and we're going to create an alignment on the part. DesignWorks allows you to first create a base plane. You can use as many points as you want. You need at least 3. The other nice thing in this feature is you don't need to use the mouse. We're going to go ahead and use the buttons on the arm to capture an X positive, Y. In this case, the origin is going to be the center of the hub. Again, we're not using the mouse to select these contours. We're actually using the buttons on the arm to trigger the commands. And notice how DesignWorks opens a sketch up on the alignment plane. So we're going to go ahead and, just so you can see where this is at, we're going to create a circle to show you where this hub sits. Again, you need at least 3 points to create a circle. You can use as many as you want. In this case, you use 3. And it's just going to give you a target area so you can kind of see where we're starting to work. Again, there's many ways you could do this. We're just trying to show you one of the most economical. So he's going to go ahead and actually capture these holes. Again, you need at least 3 points. You can take it by minimum 3, or you can drag it, or you can take as many points as you'd like. We're starting to take the holes around the perimeter. Now you could take one of these if they were a pattern, but they're kind of an oddball relationship. So again, we just took enough in the quadrant we could see what we were doing. We're going to go and capture the shape of it. So we're going to utilize the DesignWorks lock plane tool. We're going to use it more in the rudimentary format. Think of it taking a knife and slicing a section. So we're going to capture a section of this, and then we're going to revolve it. So the nice thing about DesignWorks in the lock plane is you pick a plane, or you can pick multiple. You actually hold the button down on the device and actually start scanning back and forth. You can back up, overlap, and capture the data. Notice you can also set a minimum distance. We have that set to around 10,000, so we have some fine detail we want to take. So again, we're using DesignWorks lock plane. We're simply moving it back and forth across the plane. And yes, you can back up, overlap, whatever you want to do with it. And in this case, we're going to create points because we want to draw the parametric section. You could also create a spline through there to get a freeform shape. Our goal is to capture this data and dimension it, make it parametric. So we're going to take some data, we're going to rotate it around the screen so we can see where we're working. We're going to complete it. So there's our parametric cross-section of points. Now we're going to utilize SolidWorks, and we're actually going to draw through there because we want to be able to dimension it and control it. That's one of the nice things about DesignWorks. It's a feature-based reverse engineering product. In the event this needs to be changed, we could go in and modify the dimension features of SolidWorks and make all this changeable. So we're going to add some relationships on this. The normal things you do with SolidWorks: add relationships, trim it, extend it. And once we get that done, we'll go ahead and we'll revolve that. But being able to capture that cross section that fast is really amazing. In the event it was worn, you could come back and modify all the dimensions since it's a parametric model, right? Just like created in SolidWorks. The other nice thing is you can mix and match. Notice in this sketch we used some of DesignWorks features and SolidWorks features. Now we're going to go back and we need to add something across this bottom piece. We're going to capture this data across the bottom. So anytime you're working, you can stop and start, add more features, exactly the same way you do with the normal SolidWorks sketch tools. Now that we have our section, we'll go ahead and just use the SolidWorks tools and trim everything up. Again, this is our profile. Now I outlined an axis in here that we'll go ahead and put in the model. I'll do revolve. So now we have our hub. We're going to save our part. Now we can go ahead and just mirror these to their half, these holes. Again, we're using the basic tools of SolidWorks. We'll do part of it, mirror some, revolve some. There's our holes. The key thing is this is totally parametric. It can be modified and changed at any state. If the customer has a change or some of this we find out it's worn, we can go ahead and make the modifications. Now we're going to start a 3D sketch. We're going to get the cross section of the helical gear. What I mean by that is we can go into a 3D sketch. DesignWorks works in 2D sketches, 3D sketches, and assemblies. So in this case, we're going to drag the probe down through the center of the tooth to get that helical shape. We're not sure what it is. So we're going to go down through there and capture some data. You could use a small ball probe or a point probe. So you can see we captured that 3D cross section. We're going to go ahead now and make a plane normal to the end of it. So what we want to do is actually capture a cross section of that tooth and then sweep it along that contour. Now we're going to use the lock plane tool again. Again, this tool allows you to scan with a probe or with a laser. In this case, we're using a small probe to go down through there, and gives you the ability to actually take the probe and go back and forth across the plane. The nice thing about DesignWorks, you can back up and overlap. You also could do multiple planes and reload the movement. Now again, in this case, we got it set to points because we're going to make a parametric cross section. In the event you needed splines, you could actually pick the spline option and actually create a spline through the points. In the event you need to change that spacing, DesignWorks is the only product of its type that actually can reload it. So the whole time you're scanning, it actually stores the movement of the device. So it can actually be loaded again to actually modify the cross section, or if you had multiple planes, have it come back and rescan through multiple planes. The nice thing also is, in this case, we went to wireframe mode because we're actually inside the solid. You can stop and start. DesignWorks gives you a lot of freedom. You can stop, start, rotate, zoom in, because you can see it's very intricate little data down in this tooth. So again, we are taking that probe and just going back and forth across the plane. And yes, you can back up and overlap. So now that we have our cross section, we're going to edit the sketch and we're going to draw through it. We want to control the parametric shape of the cross section. So we're going to create relationships and make it tangent. Again, this whole cross section is totally dimensionable. In the event it may be worn a little bit, or we need to make a change on it. Once we add the relationships, we'll go trim everything up. This is going to become our profile for like a cut sweep. So now you can kind of see our project taking more shape there. We got the hub, the holes. Now we have the shape for the cut sweep. If we want to start this cut on the outside, we're going to move a plane out here outside the shape, and we can do a convert entities and actually push it out there. There's a couple different ways you could do this. This is one way that you could, because you want the cut sweep to actually start out past the outside of it. So we're going to convert the entities. It's going to push them out there onto that path. When we get ready to do the cut sweep, we'll make a coincident relationship to make sure the profile is sitting on the curve. We went ahead and actually added some extra points on the curve that we're going to actually do the sweep about, because we want to extend it out past it. Now we're just taking SolidWorks and saying insert curve through reference points, because we already have the points, but we need that longer. We need to put it out there where the profile begins the cut sweep path. So at this point, we're going to do a cut sweep. We're going to pick the profile. We're going to pick the path. And you can see the shape of our tooth being cut out. We'll go ahead and add our chamfer. One of the things we need, on the inside there's a small chamfer on it, and on the outside as well. So again, the nice thing about using DesignWorks with SolidWorks in this instance is totally parametric. So you can see we have our hub, our holes. Now we're going to do a circular pattern on the tooth. Simply pick the axis. How many we need? In this case, it has to be 40. And we rotate about the axis. Now let's go ahead. DesignWorks has a validation tool. We're going to validate that groove to see how close it is to the actual part. Very easy to use. You simply pick a face, hold the probe in that area, and you can drag it or take points. So we're actually going to go ahead and take some points here. And it's actually going to tell us the deviation from physical part to model. You can take as many points as you want. We're going to take 5, 6, 10, whatever. So you can see our mean is 1,004/10. You can pick other faces. To double check it, we're going to pick the tooth right beside it. Let's see how it does compared to the rotation. This gives us a really good idea, is the rotation correct? We're going to check a second tooth. You can see again we're holding about the same. So in a few minutes we've actually reverse engineered the helical gear, and we've proven that the part is accurate back to the SolidWorks model. Stay tuned in for more DesignWorks videos. Have a great day.